What up, B's and G's? I'm back, baby. Since my last video, I moved across the country to a new city, moved into a new house, but I got a new workshop and I have some new projects to share with you guys. I've been trying to up my video editing game and quality. So one of the first projects I took on out here was making a mini rotating display table so that I can take 6 shots of things rotating, like you guys just saw. So if you are a photographer, videographer, maker, YouTuber, or want to be all of the above like me, you guys can build this yourselves. I'm going to put all the links to the parts I use in the description, and I'll also post the files to the 3D printed parts that I designed. Hope you guys enjoy the video. First thing you're going to need is a Lazy Susan to serve as the rotary table. You can get these pretty cheap off Amazon or any home goods store. This is a 10-inch one I bought for $3 at Target, I think. This is a 9-gram micro servo. You can get them pretty cheap on Amazon. These are normally used in like remote control airplanes for ailerons and flaps and things. You want to make sure it is continuous rotation, but if it is not, if you have one already that isn't, you can modify it to make it continuous rotation. I'll talk about that later. Next, you're going to need a servo tester. So this is going to control the speed of the rotary table and also send power to the servo. You're also going to need some type of voltage regulator, or in this case it's called a battery eliminator circuit, that takes some battery and regulates it down to 5 volts, since that's what most of these micro servos run on. And then finally, you're going to need a battery. I'm using a small 2-cell LiPo. That's pretty low profile because I'm trying to keep the whole package compact, but you can use anything that's above 5 volts. So 2-cell, 3-cell, 4-cell LiPos, as long as they're small enough. You're also going to need a few 3D printed parts. The last thing you're going to need is some type of enclosure or board to mount all this stuff to. I have a nice 3D printed one here that I designed that I'll put up on Thingiverse for you guys to download and print. If you don't have a 3D printer, don't worry, it is all doable with scrap wood. These are just pieces of wood I had lying around that I hot glued together to serve as the base. So I was mentioning you can get these servos in 2 different forms. Sometimes they come in continuous rotation form, and sometimes they come in like 90-degree or sometimes 180-degree form. So for this project, we want to make ours continuous, but let me show you what the difference is between the two. So you can see as I turn the knob, on the left one I go from 0 to 90, and on the right one I go from clockwise through 0, and then I go counterclockwise. Some of them will actually have a mechanical stop to prevent them from rotating. This one does not, but some of them won't let you rotate past 90 or 180 degrees. So you'll have to remove that stop. Typically it's like a nub or pin in the gear you have to take out, file, or cut out. Okay, the first thing to do to modify your servo to make it continuous rotation is to hook it up to your servo tester and use this mode button to put it into the neutral mode. So once it's in the neutral mode, now you can unplug it and take it apart. So once you have it apart, you're gonna take the main gear with the shaft that goes down into the potentiometer and you're gonna cut it. This way, the potentiometer won't know where the servo is and it won't try to correct its position when a command is given. So once you put it back together and connect everything up, you'll see that the servo will spin freely and its speed and direction will just be based on what command input you give it from the servo controller. So essentially you're controlling the velocity, not the position. All right, now we have all our components. Let's get on with the build montage. this thing has some serious torque. This little drill press is about 15 pounds and the servo can take it. All right guys, a couple final notes to help you out with this build. If you hot glued all these things in place and the Lazy Susan is not actually spinning, it's probably because this wheel is not touching the Lazy Susan. So a couple different ways you could do this. You can kind of add more hot glue to lift the wheel higher, to lift the servo higher, or you can, I'll put a couple different size wheels that you can download and print, and you can swap out the smaller ones for the bigger ones until your wheel is making contact with the bottom of the Lazy Susan. One improvement you could make is to actually put a switch here. Right now I just kind of plug the battery in and out to turn it on and off, but you could put a switch in line. One other alternative, if you don't want to use a battery or don't have a battery this size, you can buy a simple USB to 5-volt power supply cable and power it directly off of your laptop USB port. And the last caveat I'll make is that it is a little bit loud, but you can always edit out the sound when you're doing a video.